In section 1.1, we're going to be talking about the distance formula. It's actually on page 64 of your textbook, not 57 as stated. If you remember from the past, you may have had the Pythagorean theorem, and it was stated as the square of the legs of a right triangle is equal to the square of the hypotenuse. So what that means is, if we state it as a squared plus b squared is equal to c squared, and we have our right triangle, which means that there's a 90-degree angle. You can see that we've got one in the drawing. And the length of the two sides that are next to, adjacent to that right angle are going to be called side A and side B. The side that is opposite the right angle is called the hypotenuse, and that's side C. So the Pythagorean theorem says that if you square the length of A plus the length of B squared, it's going to be equal to the square of the hypotenuse, or C squared. So if we have our example and we have 3, 4, 5 around that right triangle, if we square the 3, we get 9. If we square the 4, we get 16, and add those together, we get 25, which is the same as 5 squared. So that's how the Pythagorean theorem works. My dad was a farmer, and my brother and I both had math degrees. I was actually working on mine at the time, and I was helping my dad build a hay barn with rafters. And we knew what one side was. It was 12, and we knew another side was 16. And my dad goes, "How long do we have to cut the rafters?" So my brother and I, both being good mathematicians, got down in the dirt, and we're going 12 squared plus 16 squared equals the hypotenuse squared. But before we could hardly get our stick and start writing in the dirt, my dad had the answer. You might want to pause it here and see if you can figure out what the answer is, and then restart it after you've had a chance to look at it. Okay, were you able to figure it out? If you see my drawing right here, around the outside where I have 3 times 4 and 4 times 4 and 5 times 4, our original triangle that we talked about on the first page was a 3, 4, 5 right triangle. A 3, 4, 5 right triangle in any multiple is always going to fit the Pythagorean theorem. So what we have is, my dad knew that 3 times 4 was 12 and 4 times 4 was 16. He knew because of that he had a 3, 4, 5 right triangle, and he just took the multiple of 4 and multiplied it by the 5 for the hypotenuse and got 20. So here we have then a 12, 16, 20, and if we took 12 squared plus 16 squared, it would indeed equal 20 squared. Some of you might be Wizard of Oz fans. You might want to go out and Google Wizard of Oz and Pythagorean theorem. There's actually an error in it when the scarecrow gets a brain, and you might want to go do that and listen to the clip, or review some of the other things that are out there about it, and start this back up again when you think you found it. If you took a look at what the scarecrow said, he said that the sum of the squares of the legs of an isosceles triangle. And what it actually is, it's not an isosceles triangle, it's any right triangle, which means that here you have one right angle. An isosceles triangle is one that actually has the 2 legs that are the same size. So actually, if this side was 12, then this side over here would have to be 12 as well. Or if this side was 16, this leg over here would have to be 16. So he wouldn't have entirely been wrong if it was an isosceles right triangle, but it wasn't exactly stated as the Pythagorean theorem was stated. On page 64, you see this picture down at the bottom of the page, and it goes through the derivation of the formula. What it does is it takes the formula a squared plus b squared is equal to c squared, and determine what it is if it's 2 points. So let me show you 2 points up here. This point right here, we don't know what x and y are, but it could be stated as x sub 1, y sub 1. We put these little numbers down here below. They're called subscripts, and if you wanted to type them on your computer, you would go to font format, and then it would be subscript is where you could click on it. Also, if you're using some of the other editors, they'll have a little thing for a subscript there that you can use as well. But it means that this pair goes together, their pair 1. The second pair of x and y's is up here, and they're labeled pair 2. Both the x and the y have a subscript of 2. So what we could do is make a right triangle between these 2 points. We could go straight across and then straight up. And so what they're referring to in this derivation is the distance between these 2 points right here and the distance between this point and this point right here. And then it will give you what the distance is of the hypotenuse, the one that's across from it. I'm not going to go through the derivation of it for you. It might be a little bit much, but what is important is that you have the formula. The formula is the bottom line down here, where it's the distance is equal to the square root of the parentheses around x2 minus x1 and that quantity squared plus the difference between the y's, y2 minus y1, the quantity squared. That formula is at the top of your textbook on page 65 if you want to take a look at that formula. The most important thing to remember about this is that there are 2 points, x sub 1 and y sub 1, and a second point, x sub 2, y sub 2. We'll take a look at example 6, which is on page 65 in your textbook, not page 59. And you want to find the distance between 2 points, minus 2, 2, and 3, negative 6. So we can call either point whatever we want to. I choose in this example to call the point minus 2 and 2, x sub 2, y sub 2, and I'm going to call the point 3, negative 6 as x sub 1, y sub 1. It would give you the exact same answer if you reverse those 2 points. So if we look at what we called our point, this point right here is x sub 2, or we could actually label x sub 2 right above it. This point is y sub 2, and we could put a y sub 2 right above it to keep track of it. We come down to this point, and the 3 is x sub 1, and the y1 is the y sub 1 is a negative 6. So we have our 4 things that we need to know for our formula. We write our formula down, and it has 4 things that we don't know what they are, and actually we do know what they are because we just labeled them right above. And remember when we used substitution previously that every place there was a variable or a letter we put a parentheses. So on the line that we have right here, all I did was go through and replace every x and y by a parentheses. Then I go back and I fill in the blank. So in this first blank, I need an x sub 2. We go up here and we look to find our x sub 2. X sub 2 is a negative 2. We place this in the first hole. In our second hole, we need an x sub 1. So we have to go find our x sub 1. We go directly above and we find our x sub 1, which is a 3. Then we go to y sub 2. We need to find y sub 2, and we find y sub 2, and it's actually a 2. So we place it in this hole. And then we need y sub 1, which is a negative 6. We're going to place it in this hole right here. So now that we've done this, and we've done our replacements, we need to do our math. So what we have then is minus 2 minus 3. That gives us minus 5. Minus 5 squared is negative 5 times negative 5, or 25. On the second place, we have 2 minus a minus 6. 2 minus a minus the 6 is the same as 2 plus 6, which is 8. 8 squared is 64. 25 plus 64 gives us 89. And if we take the square root of that, it would be approximately equal to 9.4. For your homework, what you can do is just leave them in this format of the square root. You don't have to do an approximation to 1 decimal point. Leaving it as square root is perfectly fine. Now what I'd like you to do is try to find the distance between these 2 points right here. And I've gone through and I've worked it out for you, but what I'd like you to do is take these 2 points, and I'm going to give you a hint. Label the first one x sub 1, y sub 1, and label the second one x sub 2, y sub 2. So I'd like you to pause the video right here at this point, and you can go ahead and take a look and use the distance formula right here and use substitution. But see if you can do this problem and follow the example above it and get the same answer. If you had a chance to look at it then, you should have gotten the square root of 40, and if you did that, then you can leave it just like that and you don't need to do anything else.